Algebra 2, Lesson 8, we're going to talk about direct variation. So when a statement of a problem says that A varies directly as B or A is directly proportional to B, this is what they're saying. A equals the constant times B. What we had here is my whatever is directly proportional or whatever varies directly is going to stay in the numerator. Okay, A varies directly, so it goes right across the equation, but I have to have a constant. All right, let's see. So A is directly proportional to B. The equation is implied. This equation that we see here is implied. This relationship is called direct variation, as opposed to later on when we'll talk about indirect variation. Okay? Or varies indirectly. In that case, what happens to the variable is that it moves below the division bar on the other side. Okay? So I don't want to get into too much of indirect variation, but I do want you to understand that there is a difference between direct and indirect. Or sorry, not indirect, but inverse variation. Okay? Let's see. So the constant k, and it will always be k. K is the letter that will always be used for variation equations. Okay? K will always go in the numerator. Always. Okay? It is called the constant of variation. The following are examples of direct variation. These are examples. They're not the only examples. They are places where direct variation is used, but not the only places. The circumference of a circle varies directly as the radius. So C equals K times the radius. Okay? The resistance is directly proportional to the length. Resistance equals KL. Okay? Water produced varied directly as the amount of hydrogen burned. W equals K times H. The little b just means burned, hydrogen burned. Okay? And really that is all that's, well, I guess we got one more thing here. There is another way to work direct variation problems in addition to the equation discussed, which I really think that the equation that you were given, that A equals KB, another way to write that, just so that you're aware, is Y equals KX. Okay? And the reason I want you to see this is because A, B are just two variables they picked out. What do we end up working with in equations more often? X and Y. So I want you to see that's where Y and X would go in a direct variation equation. But they do give you another one here where they say the statement A varies directly as B. It also implies a proportion, or because we're saying that something varies proportionally to. Well, so A1 over A2 equals B1 over B2. But I really think that this right here is going to be a better benefit to you than necessarily worrying about A over A equals B over B. What's that? Y equals KX? Yeah. All right, so from here, let's look at some questions. If I can find where I want to be. All right. Let's see. Given that Y, let's make this bigger. I don't like how small that is. Let's try 170%. Let's try 180%. Let's just try 200%. There we go. Yeah. Okay. I want it to be big enough you can see it. Given that Y varies directly with X, again, you can see why I would choose this. Find the equation of direct variation when X equals 15 and Y equals 5. So what are we going to do? So we know Y equals KX, right? All right, what's next? Okay. Okay. Given that Y varies directly with X, find the equation of direct variation. Okay. What do they have listed as your answer here? They have it as Y equals or XY equals, something like that, correct? All right. So what I'm telling you is that whenever it comes to direct variation, the first thing that we have to solve for is K. Does that make sense? Okay. So how do I solve for K here? Divide by 15 on Both sides. And if you remember from yesterday, what do we call that? What do we call that property? The division property of equality. Great job, guys. Great job. Almost needed no help / I did all of the work. All right, so 5/15, what does that reduce to? So 1/3 equals K. All right? So our equation then, let's go back up here. Y equals what? What are we plugging in for K? 1/3 X. Now I know, now I can basically, I can put in anything for my input and know what my 1/3. Right? So in these equations, your first step will always be, should always be, to solve for K, then plug K in to solve for maybe the equation or to solve for one of your other variables. Okay? So let's see, we should get B as our answer. Did that make sense to us? Okay. Let's see. I don't like this question, but because for some reason my brain never quite works with it. At a summer camp, there is one counselor for every 5 campers. Determine whether there is a direct variation between the number of campers, Y. Okay? Campers are Y, and number of counselors is X. Okay? If so, find the equation of direct variation. Okay? So Y equals KX, right? All right. So there is for every 5 campers. So we're starting with what? 5 equals K times 1. Okay, what's the first step? Divide by 1, right? So K equals 5. So my equation is Y equals 5X. Okay, Y equals 5X. I think, let me double check. I think that should be our answer. That's probably the best job I've ever done getting my head wrapped around it. Okay? So good job. It only took me 6 years. All right. Does this make sense so far? We're getting it. Plug things in for X and Y. Solve for K. All right. Let's see. I'll check again. What time do we get out of here? 10:11. What? No. On this page, it's 10:11. Unless they've changed it.
Well, mine says 10:14.
Well, maybe that's right.
Or probably we got 10:11.
Yeah, you've got your next class starts at 10:14. All right, so we got some time. Let's see. Let's keep going here. Number 3. At a constant rate, distance varies directly as time elapsed. An equation that, if you're not already familiar with it, is distance equals rate times time. All right, are we familiar at all with that equation? Basically, this is saying that my speed times the time that I've traveled is going to equal my distance. You know, if I'm going 60 miles an hour for 3 hours, my distance is going to be 180 miles, right? And I can alter that equation around to solve for rate and solve for time, right? So rate equals distance over time. Okay, that's miles per hour. We see that all the time. If you're, some of you, nobody in here drives yet, maybe, but miles per hour is a rate of distance over time. Okay, does that make sense? All right, so anyway, at a constant rate, distance varies directly as time elapsed. In this case, my constant is my rate. So we're switching out, instead of R, we're going to have K there. Okay, see how I really niftily turned that R into a K? You can't even hardly notice that the R is even there now. So anyway, the speed of sound in air is about 335 feet per second. Okay, how long would it take for sound to travel 11,725 feet? What am I trying to solve for? Am I trying to solve for distance? I'm trying to solve for, no. How? Look at the last sentence. What does it say? How long? Okay, what is that asking for? Is it asking for distance? How? Okay, let's look at it some more. How long would it take? So what are we asking about? We're asking to solve for time. Okay? Now, let's see, how the speed of sound is 335 feet per second. Right? What is that? That's my rate. That's my speed. That's my constant. Okay? So we have 335, okay, t, and what is my distance? Okay, and I want to solve for t, so how do I do that? Divide both sides by 335. That is what property of equality? The division. There we go. We're getting it. We're getting the names of it. All right, so what's 11,725 divided by 335? I'm just betting off the top of my head that it's maybe 35 seconds. Is that right? Man, I'm good. Do we want to work out some more questions together, or do you guys feel like you guys got this down well enough that you can get started? That sounds rather uncertain. Okay, number 4. The number of yards, okay, yards varies directly as the number of feet. All right, do we understand how I wrote that up? Okay, there are 9 feet, okay, in 3 yards. So 3, that's my yards. K 9, right? All right. No relation to dogs or anything like that. If Leah walked 60 feet, how many yards did she walk? Well, let's find out what our constant is. What are we going to do with 9? Okay, so what is K? What is K? It'd be 3 divided by 9, which is going 1/3. K equals 1/3. So if Leah walked 60 feet, all right, we want to know how many yards she walked. So we're going to say y equals 1/3 times 60 feet. Okay, so we're going to take 60 times 1/3, or 60 divided by 3. How many yards did she walk? 20 feet, or sorry, 20 yards. Yards was 20. Now, that question, we're familiar enough with the units involved that we could have solved that without going through the direct variation means, right? We could have said, okay, well, I know that there's 3 feet in a yard. So if she walks 60 yards, I would just divide that by 3. But I want you to see how the math actually works with direct variation, because you might work with units that don't necessarily make that kind of sense in your head. Okay? Are we getting it now, or do we want to keep working out some questions together? One more? Okay, why don't you pick one? All right, and I think this goes on maybe to a whole nother page. Yeah, there's 12 questions. We have done 4 of them. So look through 5 through 12. What'd you say? You want to do 12? Okay, let's look down here at number 12. The following measurements were taken of a tree. Do the age and height show direct variation? If so, write the equation of variation. If not, explain why not. Okay. So, let's see. What we want to find out if there is a constant. Okay? And in order to do that, what we're going to do is we are going to divide. Okay? What's 5 divided by 1.4? Okay, because remember, let's say this is y and this is x, right? Y equals kx. So we're saying 5 equals k 1.4. So that's why we're dividing 5 by 1.4. Okay, to find out what the constant is. As we look at this, what is 5 divided by 1.4? 3.57. Now, in order to find out if there's a direct variation with the data, I have to do that with each one of these sets. Because if the constant is different, then there's not really a constant there, right? We have to have a constant, and the constant has to be constant for it to be direct variation. So what's 8 divided by 2.24? 3.57. Now, just because those two work doesn't mean that one of these others is not going to work. So what's 13 divided by 3.64? All right, can I just stop there and say, hey, 3 out of 4, the last one's probably good. I don't have to worry about that one. No, better do it, right? What's 15 divided by 4.2? Okay, so now we can say, yes, the ratio of the age to height remains constant. Okay, so in this case, I think they do something a little different. They actually, I think that they maybe flip it around. And they make, and I probably am wrong. Now, granted, there's still a constant either way, but because your x is your independent variable, right? It's not dependent upon anything else. Okay, your let's see, your x should be your age and your y should be your height because your y is dependent upon. Typically speaking, height is dependent upon age. So really the number that we should get through here, if I didn't make this mistake, should be 0.28. Go ahead and real quick for me check. What is 1.4 divided by 5? All right, and if you do it right through here, you should get 0.28 all the way through, which means my equation is y equals 0.28x. Okay? If I plug in an age for x, I should be able to find out the approximate height in y. Okay? That we follow that? Now, granted, your age has to be in months for it to work, but it works. All right, and we don't have to explain why because it worked. Okay, my constant was 0.28, and that was my equation. Any questions? Okay, great. I will stop this right here. You guys can work.